In this lesson, you will learn about other similar figures. Recall the meaning of similar triangles from Lesson 1. Similar triangles are two triangles that are similar if their corresponding sides are proportional and their corresponding angles are equal in measure or congruent. So any two figures can be similar if their corresponding sides are proportional and their corresponding angles are equal in measure. So for example number 1, we're going to determine if each pair of figures are similar. So let's first start with the sides. We have QR, and we're comparing that with LM. So QR with LM, we have 5 to 10, so that equals 1/2. In order for these to be similar, we then also need to see that the other pair of sides are proportional and equal 1/2. So we're going to compare RS to MP. So 15 to 34. When you reduce the fraction 15 to 34, it will not reduce. So that means it will not equal 1/2. They are not similar because the sides are not proportional. Not similar because the sides are not proportional. We do see that the angles are equal in measure, but this proportionality does not hold true, so they are not similar figures. Let's look at example 2. This is supposed to be a 42. So comparing the sides, let's start with HA. So HA, and we're comparing that to LU. Notice they also share the same measurements as PR and ET, so we can say that all of that is equal. PR. So those measurements are 27 to 36. 27 to 36. It does reduce to 3/4. So that would mean when we set up the other ratios of the sides, they will also need to equal 3/4. So let's try HP to LE. So HP is 42, LE is 56. When we reduce that fraction, 42 to 56, we once again see 3/4. We will need to continue comparing all sides, so AR to UT, to make sure that all sides are proportional. It is not enough to stop just seeing that these sides are proportional. Every side would need to be proportional with corresponding sides. So AR to UT. So 6 to 8. Does reduce to 3/4 once again. Even though we don't know anything about the angles, we can just see by the sides that all the corresponding sides are proportional, so they are similar because those sides are proportional. Let's look at example 3. So first notice our angles. We have angle E that corresponds to angle N and angle C that corresponds to angle L, or vice versa. Because those are one marking, they're actually congruent to measure, so it would not matter which one they match up to. Same with angle D and B, they match up with M and O. So our sides, 21, since it's they're all 21, so 21 can match up with 23, and each time we see that, so each side ED matching up with, E's the one marked angle, so we'd have to start with N. NM is the same as DC, which is ML in this one. And then CB, which would be LO. Oh, CB, and then LO is in the denominator. And finally BE, which goes with the 2 marking to the, I lost track. 2 marking to the 1 marking, so we need O to N is the last one. So we went all the way around this figure E, D, D, C, C, B, B, E with the corresponding parts starting at the 1 angle mark like we did with E. N, M, M, L, L, O, and then finally O, N. So because all of those are the ratio 21 to 23, we do have proportional sides since they all equal the same, and the corresponding angles are also equal. E and N are equal and measured, D and M, B and O, and C and L. So all corresponding angles are equal. So we do have similar figures, because of those proportional sides and our corresponding angles are congruent. Let's look at our last one, number 4. Again, notice starting with our angles, we have a 1 marked angle, but we do not have that anywhere in this figure. So already we see that our corresponding angles don't have any equal measurements. I know we have this angle K that can correspond to W, an angle M that can also correspond to W, but 2 angles cannot correspond with 1 angle in the other figure. So just by the angles, it's enough to say they are not similar. If you wanted to start by looking at the sides, notice all of these sides are equal to 20, where over here, our measurements change within the figure. So whether you look at the sides or you look at the angles, we would not have similar figures. Not similar figures. Our corresponding angles are not congruent, and our corresponding sides are not proportional. Let's look at example 5. Each pair of figures are similar. We're going to find the missing side. Because we know the sides should be proportional, we can set up an equation to solve. I prefer to always start with my missing value first and then match it with its corresponding side, so 3. So x3 would be our first ratio, and then pick any side in that first figure. Since we started with this figure that had the missing side, we need to go back to this figure. So pick any value. You can pick the 40, the 56, or even this 56. I'm going to go with the 40, but it will work to use any of those values. So because I picked the 40, I have to pick the value that corresponds in this other figure, so 10. If you would have picked the 56, you would have needed to pick the 14, as long as you're picking the values that correspond in each figure. Now we cross multiply to solve. So 10x equals 120. Divide by 10, and then we find x equals 12. The value of this side of the figure is 12. You could plug that back in to make sure it's still proportional. 3 to 12, 14 to 56, 10 to 40, to making sure all the sides are still proportional. Let's look at another example, number 6. Again, I like to start with my missing side, so x over, go to the corresponding side in the other figure. So x is going to correspond to the 90. Pick another side, so you can pick the 13 or the 9. I'm going to go with the 13. That 13 corresponds to this side, 130. It would have also worked if you wanted to pick the 9 for the numerator. The 90 would be your denominator, as long as you're picking numbers that correspond within each figure. So cross multiply to solve. You get 130x equals 90 times 13 is 1,170. We divide by 130. We get our x value of 9. And finally, for example number 7, again, start with the missing sign. Be very careful that you match it with the corresponding side. That's the longest side of this figure, so it needs to correspond with this longest side of the figure. If you have a hard time telling, look at the other marking sides. This is the short side. 4 is a little bit longer, but not by much. So come over here and find. Here's the short side, and a little bit longer, but not by much. So the x corresponds with that 91 because it's the longest piece in between those two things. So x corresponds to 91, and then pick any of those numbers in that figure, the 3, 12, or 4, whichever is your favorite to work with. I'm going to go with the 3 because it's the smallest number. And the 3, again, we already talked about, is the shortest side, so we're going to find the number that it corresponds to, which it makes sense to correspond with the 21 because it is the shortest side. So when we cross multiply, we get 21x equals 91 times 3 is 273. We'll divide that by 21 to solve for x. And we find value of our x is 13.